Hello everyone, and welcome back to the last episode of STEAM TV from the North Hastings Public Library. My name is Emma Dafo, and I am so excited to bring today's episode to you. Today we're going to be learning about math with two super cool activities. So let's jump right into it. The first activity we're going to be doing is what is known as a multiplication cootie catcher. Now you may have heard of cootie catchers. I know I made a lot when I was younger. So if you have done them before, this should be quite an easy experiment for you. So the first thing we're going to do is we need to take this rectangle that we have and make it into a square. So to do that, we're going to take one corner and fold it all the way to the other side, making a triangle, just like that. And now we're going to take this piece, take some scissors, and we're going to cut it off. Now, whenever scissors are involved, I always suggest adult supervision. Just make sure to be safe. Now, you can see we have a square. How cool is that? And you can also see there's a crease down the center, just like that. Now we want to make some more of those. So we're going to take the corner on one side of the crease and fold it to the other corner, right in half, to make a triangle. And now our square is split up into 4 triangles. Then we're going to take one side and fold it to the other. And then we're going to unfold that and repeat it. So we have kind of a star pattern on the inside on our square, just like that. Now we're going to take one corner of the square on the inside where it's folded and fold it right into the middle along those creased lines that we have, just like that. Fold it right there, so it's just touching the center. And now we'll do that with all of the other corners. So then we have a smaller square. And then we're going to flip over our square to the side that does not have any flaps in it and fold in those corners in just the same way we did with our bigger square. So we can make an even smaller square. So then it looks like that. And then we're going to take that, where the triangles are on the inside, and fold it in half that way. Then give it a good crease, open it, and fold it in half the other way. Now, you'll see there are little pockets on the outside. Simply put your fingers into them and move your fingers towards each other, and you have a cootie catcher. Just like that. Now, we have the cootie catcher part, so we need to add the multiplication. Now, the first thing we're going to do is need to choose 4 colors. So I have pink, red, green, and blue. So with my cootie catcher still folded in half, I'm going to start with pink. So I'm going to take a pink marker and write pink on one of the folded squares, just like that. So one of the places you would put your finger into as like a little pocket, you're going to write pink on it, just like that. And then color that square pink. Now you can of course decorate this more. You just require the name of the color written on the outside. So once I have it all colored in, I'm going to take my red marker on the square beside it. I'm going to write red, and then I'm going to fill it in with my red pencil crayon. Just like that. like that. So we have pink and we have red. Now I'm going to turn it over and choose two new colors. So I have blue and I have green. So I'll start with blue and write blue. And then take my blue pencil crayon and color it in. Just color the whole square. And then I'm going to take my green marker, write green, like that. And then I'm going to color it in using my green pencil crayon. And there you go. We've got blue and green on this side, and then red and pink on that side. So when you unfold it, they should look like that. So the red and the pink should be upside down to the blue and the green, or vice versa. And now what we're going to do is write some multiplication questions on the inside. Now you'll see these big triangles here. They have a line down the center where we folded. So we're going to divide it into two triangles and write a multiplication question on each of them. Now I'm going to do the 2's times tables because I know the answers to those questions, so I don't have to use a calculator to look anything up. But if you'd like to do harder ones, you can certainly do that, or perhaps get a friend to make it for you, so then you don't know the answers and have to practice in earnest. Now I'm going to start 2 times 0, then 2 times 1 on the square there, or on the triangle there, sorry. And then I'm going to move my square around and do 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, and then 2 times 7. So now there are multiplication questions written on every single little triangle in there. And now I'm going to open up the triangles where each multiplication question is, and this one right here is 2 times 0. And I know anything times 0 is 0, so in the triangle right below it, I'm going to write the answer as 0. And then we have 2 times 1, and the answer is 2. Now I'm going to go around and do that for all of the other questions. And there we go, it's all filled in. And now we're going to need to do some more coloring. So I'm going to take my green pencil crayon and I'm going to color 2 of our little triangles. Now they don't have to be side by side, they can be wherever you want them to be. I'm going to do mine side by side, I think. And then once those are colored, I'm going to lift it up and color both of the triangles underneath where the answers are green. This will just make it easier for me to know that I have opened the right flap and know that I have the right answer. Now I'm going to do the same thing with red. Color the answers, and then I'm going to take my pink and color 2 triangles as well as the answers. And then finally, I'm going to take my blue and color the answers first this time, and then the 2 triangles. And the cootie catcher is finished. All I have to do is fold it back up, put your fingers in the little pockets, and there you go. You have your very own multiplication cootie catcher. Now how I suggest you use this is picking a color on the outside. I'm going to go with green. Now every time I say a letter of green, I'm going to open and then close the cootie catcher. So we have G, and then I'm going to close it. R, open it the other direction, close it, E, E, N. And now I'm on the last letter, so this is where it's going to stay open. So I'm going to take a look. I have got 2 blue triangles and 2 pink triangles. I'm going to go with pink. So I'm going to close it, then go P, I, N, K. So I'm back here, and now I'm going to go with 2 times 7. I'm going to choose that multiplication question. Now I believe that is 14. So now that I've given an answer, I'm going to lift up my triangle, look for the blue underneath, and would you look at that? It is 14. Now I'll give you another example. Let's say I picked red. So we have R, E, D. Then I'm going to go with blue, so B, L, U, E. And then let's see 2 times 3, which I believe is 6. So I'm going to open it, and there we go. I've gotten that one as well. So that is essentially how you can use your cootie catcher. Now I've used 2 times tables. You can do random multiplication questions. You can do 3s, 4s, 5s, 6s, 7s, whatever you want to do, whatever multiplication you need to learn. Or you can do addition or subtraction or division. I just think that this is it's a good way to help you to memorize with a little bit of fun in the process. I know I always loved using cootie catchers when I was little, and I would say the same thing now. They're quite enjoyable. In any case, you can also make more than one to learn multiple different types of math if you would like. And we can talk about the importance of multiplication here. Now, multiplication is quite important in math. It's a fairly, it's a mathematical concept that you can learn when you're quite young, and it's built on as you move through school. Having just completed grade 11 math myself, it's hard for me to think of a situation where I didn't need to use multiplication, and it's quite important in very many mathematical processes, concepts, that sort of thing. So I think it's really good to have a solid understanding of multiplication and anything else you want to learn, addition, subtraction, division, just because it can really help you later on to build on these concepts and to really learn some super cool math. And I think the cootie catcher is a fun way to do that. If you're a visual learner, it might help you in that respect, and it could help you spell your colors if you're not quite there yet. And yeah, it's a fun little activity for you to do, and it doesn't quite feel like homework. It's more of a game than doing worksheets and things like that. Now, there are tons of mathematical resources here at the North Hastings Public Library. We have so many things that you can come in and you can use that are more than just worksheets or anything like that, that can really help you to learn. We have an awesome experiential learning collection. We just got some new math kits, which are super cool. You can also check out the description of this YouTube video for some awesome websites, including the blog Artsy Fartsy Mama, which I'd like to thank for this wonderful activity. It was super fun to read about all the applications that they used for it and to kind of make it my own. And yeah, with that completed, I think we can move on to the next activity. Now, the next activity is totally different, which is quite helpful because it can teach you some different concepts. I really liked researching this one. It was truly fascinating, something I'd always kind of known about but never really gone too in-depth with. So it was really fun for me to learn about it. Now, this one is called the Fibonacci Art Project. Now, for this activity, you're going to need some construction paper. I have 3 different colors. It just makes it look a bit more fun. In my opinion, you're going to need some a compass and a pencil. Compass just like that, and a nice sharp pencil. you're going to need a ruler, some glue, and some scissors. And I suggest some nice hard cardboard. You can see me working on it here, just because the compass has quite a pointy little end, and it can really dig into your table. And the cardboard prevents that. Also with this, I suggest again adult supervision. The compass is quite pointy and it can be really difficult to use as well, so it might be nice to practice with somebody who has experience using one of these. And again with the scissors, of course, please be careful. You never know what can happen, so make sure to pay attention and be careful. Now the Fibonacci sequence, before we get into our activity here, is a number sequence where each number is the sum of the previous two numbers. Now a sum is, it's like a product when you add two things together. So if you added 1 and 2, the sum would be 3. Now normally the Fibonacci sequence, it depends where it starts. It can start on 0, it can start on 1, but for today's project we're going to start with 1, just because it's easier for us to start there with this activity. So it goes 1, and then 1, 2, 3, 5, 8, 13, and so forth. You can see 1 plus 1, their sum, or what they create when they're added together, is 2. And then if you add 2 and 1, the number before it, they create 3, which is the next number. And then we have 5, which is 2 and 3. And then we have 8, which is 5 and 3, and then 13, which is 8 and 5. So it goes like that, on and on and on. Now we're going to use this sequence of numbers to make a super cool art project, which can help us to visualize the sequence and understand it a little bit better than just me telling you what it is. So first, we're going to take some construction paper. I'm going to start with some yellow, and we're going to need a ruler and a pencil. So we're going to draw a line that is 1 centimeter long, because that is the first number that we're using today. So we'll draw 1 centimeter, and then we're going to need to mark the middle of that. Now half of 1 is 0.5. So you can see that is usually marked on the ruler with not quite as big a line as used for whole numbers, but it's a fairly large line. Then we're just going to mark that. I can show you how I did that up top there. And then we're going to place the compass point right on that little mark that we've drawn for 1.5. We're going to put the pencil at the end of our 1 centimeter line, and we're going to draw a circle. Now this can be quite difficult with the little circles. And there we go. That's what mine looks like. Now I'm going to label this 1 centimeter so I know where to put it in my sequence later on. And then I'm going to go ahead and cut it out. Now I find it's easier to cut off a little bit of the paper, so I do it closer to the outside of the paper so I don't waste a lot, just when cutting out circles. And it does not have to be perfect by any means. This is just a fun art project to help you visualize the Fibonacci sequence. Now, there is our circle. Just like that, just a tiny little circle. And next, I'm going to take a different piece of construction paper. I'm going to take some pink, and we're just going to repeat that. So we're going to draw 1 centimeter, mark 0.5, and draw the circle. Now I'm just going to adjust my compass, or my pencil a little bit, just so the end of my pencil is about even with the tip of my compass. And then I'm going to draw a circle. And this is 1 centimeter again, because the second number in the Fibonacci sequence is 1. And there we go. That was a bit of a tricky one. Alright, 1 centimeter on it. And then go ahead and cut it out. And there we go. There is another little circle. Now I'm going to go ahead and pick up the orange construction paper and do the next number, which is the sum of 1 and 1, which is 2. So I'm going to take my ruler and my pencil and draw a 2 centimeter line this time and mark the middle, which is 1. And then I'm going to place the tip of my compass on that mark for the middle and place my pencil at the end of the 2 centimeter line and draw a circle. Now that one was much easier for me. I find they're much easier when they get larger. Now I'm just going to mark that as 2 centimeters so I can place it in the correct order when we go to put this into our art project. And then I'm going to carefully cut it out. And there we go. And make sure to set these somewhere safe so you don't lose all your little circles. But there is the 2 centimeter circle. Now I think I'm going to go back to yellow and make the next circle. Now 2 plus 1 is going to be 3. So we're going to take our ruler and draw a 3 centimeter long line. Now 3 divided by 2 is 1.5. So we're going to mark that as the middle. Place the tip of our compass in the middle and the tip of our pencil at the end of the 3 centimeter line. And then we're going to draw the circle. Don't worry if you get little lines places because your pencil has moved or your compass jumped or anything like that. You can cut around them, and we're going to turn this over in the end anyway, so it's not a big deal. Then just mark it, just like that, as 3 centimeters, and then we're going to cut it out. Now, you might be able to figure out what the next one is already. So we've just done 3, and we did 2 previously. So the sum of those, or what they add to when they're put together, there's my 3 centimeter circle, is going to be 5. Now I think I'm going to take my my pink construction paper for this one. And now the next number is 5, so we're going to draw a 5 centimeter long line. Now 5 divided by 2 is 2.5, so that's going to be our middle, so we're going to mark that. Place the tip of our compass on the middle, the tip of our pencil on one of the ends of our 5 centimeter long line, and we're going to draw our circle. Now, as you can see, I go back and forth a couple times. This just helps to make the line a little thicker so it's more visible. And then I'm just going to mark it and go ahead and cut it out. Now, as the circles get bigger, you're going to want to put them a little more into the center of the page, just so your compass doesn't run off your paper. So there we go. There's our 5 centimeter circle. And next, I think I will grab the orange construction paper And the sum of 5 and 3 is 8. And the middle of 8, so 8 divided by 2, is 4. So we're going to mark 4 centimeters on our line and do what we've been doing. Place the tip of the compass on that line, the tip of the pencil on the end of the 8 centimeter line. Now you can see here I'm guiding the compass or the pencil with my hand and holding the compass with my other hand. This just helps me to make a more steady circle. I'm just going to label it 8 centimeters. And you can see there it's a bit more pressed into the paper. A bit of a darker, nicer circle. And then I'm just going to cut it out. An 8 centimeter long circle. Place that with our other ones. And for the final circle we're going to be doing, I'm going to take some yellow and my ruler and my pencil, and now 8 and 5 make 13. So I'm going to draw a line that is 13 centimeters across. So the middle of 13, or 13 divided by 2, is going to be 6.5. So then I'm going to take my compass, place it on that line that I just marked at the middle, place my pencil on the one end of our 13 centimeter long line, and I'm going to guide my pencil around with my hand. These ones definitely take some more time, but there we go. There's a nice big circle there. And then just label it as 13 centimeters, and we're going to cut it out. And there we go. That's all of our circles. I'll set my paper aside and bring the circles back on to my workspace. Being careful not to drop any of them. And there we go. So we should have 2 1 centimeter circles, 1 2 centimeter circle, 1 3 centimeter, 1 5, 1 8, and 1 13 centimeter circle. Now, you can arrange these circles. I suggest beginning with the largest one on the bottom and ending with the smallest ones, the 1 centimeter ones, on the top. I also suggest turning them over so you can't see all of your markings on them. And then arrange them however you would like. I can show you how I'm going to do mine. You can do them in any way that you would like. Just use your glue stick and place them on a larger circle. So that's what I have so far. That's my 8 centimeter circle on my 13, and then I'm going to take 5 and put it on my 8, and then take the 3, put it on the 5, and then the 2, put some glue on it, put it on top of the 3, then I'm going to take the 1 and then the last one and put them on top. And that's what mine looks like. So I've just put them all on the outer edge of each circle. So it's a cool little project that shows you that this is what the Fibonacci sequence actually looks like. Now, you can also change the numbers that you've used. You could, for example, divide the first term of the sequence by 2, which we said is 0.5, and just go from there. So you would have 0.5, 0.5, and then 1, and then 1.5, and so on and so forth. And that makes it so you can have more circles on a smaller area, so you're not getting a really large project. If you want to make a really large project, you totally can. Yeah. Now, what is the purpose of this? Why should we learn about the Fibonacci sequence? Why is it important? Well, according to Live Science, a website I've listed in the description, the Fibonacci sequence is one of the most famous formulas in mathematics. It's named after Leonardo Fibonacci, who was an Italian mathematician born around 1170 AD, which is a really long time ago. There are many sources, however, that don't believe that he created the sequence. It's said that ancient Sanskrit texts, Sanskrit is a language of India and is one of, if not the oldest language in existence. It's now mainly a language of worship and ritual as opposed to speech, but even so, it's a very, very neat language that I would love to look into someday, hopefully. We'll see. Anyhow, it's said that in ancient Sanskrit texts that use the Hindu-Arabic numeral system, it's mentioned there first, which predates Leonardo Fibonacci by centuries. Now, in a book by Leonardo Fibonacci, he introduces the Fibonacci sequence with a problem involving rabbits. It goes as follows. Start with a male and a female rabbit. After a month, they mature and they produce a litter with another male and female rabbit. A month later, those rabbits reproduce and out comes, you guessed it, another male and female who can also mate after a month. Now, you have to ignore the wildly improbable biology here, of course. It is just for the instance of the kind of visualizing the equation or the sequence. After a year, how many rabbits would you have? The answer, it turns out, is 144. And the formula used to get that answer is what's known as the Fibonacci sequence. Now, Leonardo Fibonacci was the first to introduce the sequence to the Western world, which is like Canada, the US, kind of over here. However, it was mostly forgotten until the 19th century, when it was worked on as more and more mathematical properties were explored. Now, the Fibonacci sequence is tightly connected to the golden ratio. The golden ratio is approximately 1.618, which is the ratio of the numbers next to each other in the Fibonacci sequence. For example, the number 2 follows the number 1 early on in the sequence, and their ratio, 2 to 1, or 2 divided by 1 divides to equal 2. Now, I know I've just said the golden ratio is about 1.618, but as the numbers increase in the Fibonacci sequence, the ratio gets closer. So the ratio 3 to 2, or 3 divided by 2, that's 1.5, which is much closer than 2 to the ratio. And then we have 5 to 3, which is 1.67, and then we have 8 to 6, which is 1.6, and then 13 to 8, which is 1.625, 21 to 13, which is 1.615384662, and so on. And you can see that the ratio, the last ratio of 21 to 13 is the closest out of all the aforementioned ratios to the golden ratio. So you can see that it does get closer as you go through the sequence. Now, from these ratios, mathematicians can calculate what is known as the golden spiral. It is a logarithmic. A logarithm is the power to which a number must be raised to get another number. It's a logarithmic spiral whose factor is equal to the golden ratio. Now, the golden ratio is present in some types of plant growth in nature, from the spiral arrangement of leaves or petals on some plants to the seeds in a sunflower. So we're able to find the Fibonacci sequence not only in mathematics, but also in nature, which is crazy. Now, this goes to show that our world is super complex, and as with all the other STEAM concepts, everything overlaps. It's very difficult, for example, to have science without math, or engineering without art, and so And now, as we reach the end of the North Hastings Public Library STEAM TV, I would like to thank you for watching and learning along with me. I had so much fun making these videos, from researching them and super cool concepts involved in them, to doing these awesome experiments and activities like this one. And I have learned so much and hope that you have as well. Now, if you've not seen the previous episodes of STEAM TV, I suggest checking them out. They were a lot of fun for me to make as well, of course, and they cover each individual aspect of STEAM. So if maybe math isn't what your passion is, you could go and you could find science, technology, engineering, and art. Now, if you've not yet, and you can also check out the websites, of course, in the description of this video to learn more, as well as the North Hastings Public Library's Instagram, Facebook, YouTube, and Pinterest accounts for more information. And as always, we are a library. We have tons of awesome books and resources that you can check out, which can help you learn, from Lego and math kits to books about these super cool formulas and all kinds of things like that. We have lots that you can tap into to help you learn. I've also put a link to a PDF of the formula for the golden ratio and the Fibonacci sequence in the description of this video. Give them a try. See if you can figure out how to use them. I was able to figure it out and found it quite interesting. And if you need some assistance, I am more than happy to help. I can show you how I have done it. You can reach me in the comments below, or the North Hastings Public Library's Instagram page, which is where I mainly spend the bulk of my time. I would also like to say a huge thank you to the blog entitled What Do We Do All Day for this awesome activity. It was really fun to adapt into my own sort of activity and to research the really cool science and math and all that sort of stuff behind it. Now, as a parting thought, as we end this super fun TV YouTube series that we've been doing, I would like to quote Dr. Marcelo Gleiser. He said that the most remarkable property of the universe is that it spawned creatures able to ask questions. This may seem self-centered on humans, but if you think about it, it's a pretty remarkable thing, right? We see all these amazing things in nature, in the world around us, and we think to question them. So remember to always question it all. Ask questions about everything. You now know that something so commonplace and seemingly insignificant as a sunflower can hold mathematical formulas and mysteries that still puzzle us as a society after years of study. Thank you for watching. I hope you have enjoyed, and I hope to see you at some point in the future. Thank you very much. Goodbye.